All right, so everybody's favorite topic, we got a motion graphs question. So we're asked for which graph represents the motion of an object traveling with a positive velocity and negative acceleration. So we can look at these separately and cross the things out that don't have them. So first, let's look at that negative acceleration. Right, before we even go into what negative acceleration is going to look like versus positive acceleration, any acceleration on a position time graph, right? Well, what does acceleration mean if we have an acceleration? That means that our speed is changing, right? And if our speed is changing, or velocity is changing, then we should see that on this graph, right? And how do we see the speeds on a position time graph? Well, that's change in position, right? Change in position is displacement. So change in position is d, right? And then d divided by t, which is going to be our change in the thing on our y-axis divided by time, which is our change on our thing on the x-axis. So that's a slope. So anytime I have a constant slope on a position time graph, that means my speed is not changing. So I can cross off this one and this one because both of those describe a constant speed. The slope here is the same as the slope there. The slope here is the same as the slope there. And then I can go into, well, if I have a positive velocity, that must mean I'm getting further and further away, right? I'm getting farther from where I started. Whereas in this one, the position is getting closer to zero. That's not a positive velocity, right? I have to go here where I'm getting farther away from zero. And that's when I see my positive velocity and negative acceleration. It's negative acceleration, not positive acceleration, because if I calculate the slope there, I'm going to get a much bigger number versus if I calculate the slope there. So my object is got a positive velocity the entire time. It's still going away from zero, but it's slowing down, which is why it's a negative acceleration.